So today we're going to be talking about scatterplots, correlation, and regression, some of which you did in Algebra 1, and then we're going to be adding a lot more details to what you learned way back in that class. So correlation occurs between two variables when the values of one have an association with the values of another. So a lot of times students think that association is the same thing as linear correlation. So you can have correlation that is not linear. Anytime you have any type of association between two values, it's correlation. Linear correlation occurs between two variables when the pattern of their association can be approximated by a line. So it's not just, that they're connected, it's that their connection actually makes a line or something very close to it. We have what's called the linear correlation coefficient, and this measures the strength of the linear association. Linear correlation coefficient is denoted by R. That's the variable that we use to represent the linear correlation coefficient. So when they ask, what is the value of the linear correlation coefficient, you would say R equals, or R is approximately, and then you would give the number value. A p-value, which we will do a lot with in the last couple chapters of this class, but here just a basic introduction. A p-value is the probability of getting paired sample data with R at least as extreme as the given data. So basically, how likely are you to get data that gives you this strong of a correlation or more? The regression line is the line that best fits a scatter plot of the data. It's also sometimes called the least squares regression line. So just so you know, that's the exact same thing. Least squares line, least squares regression line, those all mean the same thing. So the correlation mantra from chapter 1. If you did your reading in chapter 1, one of the things that the author stressed is now becoming extremely important here in chapter 2. And that is that correlation does not equal causation. Just because two variables have an association does not mean that one is the cause of another. So just because we decide that data has linear correlation or does not have linear correlation, that has absolutely nothing to do with causation. We need different types of data for that. So there are going to be 3 ways that you are going to be asked to decide if data has linear correlation. So make sure that you pay attention to the directions for which way they specifically want you to do it. So if we want to be able to conclude that an apparent correlation isn't due to random chance, we need our p-value to be very small. And the threshold number that we use for that is 0.05. So if our oops, I don't know why I have R there. If our p-value is less than 0.05, then we're going to say that this has a pretty strong linear correlation. Now, of course, in order to find that p-value, we need to know how to do that. And so I've typed out here what you would press into your graphing calculator. in order to get it to spit out the p-value for you. And we will actually do this with the example at the bottom. We will use all three of these ways with the same data so that you understand how to do all of them. So this is what we'll use when we get to that example. So once you run all of this in your calculator, it'll spit out the p-value. If it's less than 0.05, we say yes, there's linear correlation. If it's not, then we say no. The second way that we decide if data has linear correlation is based on critical values of R. So not just R itself, which is method number 3, but on the critical values of R. So in your book, at the very back are a whole bunch of tables. And tables used to be the main way that we dealt with things in stats class. And in AP stats, they still use tables a lot. We really, because we have better technology now, we do most of the things that used to be done with tables in our graphing calculator. But this is one exception where I am going to teach you how to use the table. So if you go to the back of the book to table A6, you'll see something that looks like this: critical values of the Pearson correlation coefficient R. And I need to make this a little bit smaller so that we can see it. This one that I have is actually straight from the formula sheet that you get to use on the midterm and the final. So most definitely you don't have to memorize any of this. Also, I changed this in the back of the book. It's correct, but on the formula sheet for some reason they had like 0.5 instead of 0.05. So on that, it provides critical values for R based on the number of data points, which is n. So how many pieces of data are we looking at? That's what we are going to use to determine our row. So here's n. So if you have only 5 data points, we would use this row. If you have 40 data points, we'd be down here. So based on how many data points we use and a given alpha, that's what this Greek letter is, and that's what is in the other column here. So sometimes they'll tell you to use alpha equals 0.05. Sometimes they'll tell you that we want to be even pickier and use 0.01. If they don't tell you at all, then you look at both of them and make a decision based upon whether it would have correlation for one column for the other, if it has it for both, if it doesn't have it for both. But that's how we're going to use it. If your R value that you've found, the actual correlation coefficient itself, is greater than the critical value, or if you're given a negative R, because R can be positive or negative, all you would do is just change the signs in this table. So if the R that is spit out to you by your calculator or given to you by the problem itself is negative, then for instance here, instead of using 0.878, we would change it to negative 0.878. So it's as simple as just changing the sign. So if R is greater than the critical value or less than the opposite of the critical value, then we conclude that there is linear correlation. If your R is between the opposite of the critical value and the critical value itself, then we conclude that there is not linear correlation. So we find the values in the table, we compare them to our R, and then we get a decision just based upon that. The third method is based only on R itself, which is used a lot in more simple math classes like Algebra 1. But notice that I put in parentheses here. You really should only use this method if if it's impossible to use the other two. So meaning if they don't give you the actual data values in order to calculate a p-value or an r-value, that might be a case where if you just have r but you don't have anything else, you don't know how many pieces of data there are, for instance, and so you can't use the critical values, or you don't have the data itself, so you can't get a p-value. Sometimes we have no choice but to just use R itself. So what we're basically doing is we are trying to decide based on R itself if we think it's strong enough. So if R is very close to 1 or to -1, then we're going to say that there is linear correlation. If R is close to 0, then there is no correlation. Now, sometimes we break it down even further. So we say, okay, if it's really close to 1 or -1, we might say, yes, there's strong linear correlation. Maybe if it's, somewhere between 1 and 0, so maybe 0.6, you might say, there's weak linear correlation. But the 1, -1, if it's really close to that, we're going to say yes. If it's close to 0, we're going to say no. And again, this method 3 is our last resort. We really try not to use that if we can help it. All right, so now we're going to go through an actual example of calculating these things. So we are going to use this data. It has the weights and fuel consumption of various vehicles. So we are going to decide using all 3 methods if the variables have a correlation. So first thing we need to do is we need to enter our data into our lists. So I'm going to pull up my calculator here. You should get yours out if you don't have it out already. And we're going to go into Stat, as you might imagine in a statistics class, and we're going to choose choice 1 for edit. We are going to edit our list. Now you can see I already have some data in my lists. So there are 2 ways that you can get rid of that data. One is to scroll up until the list itself is highlighted and then press clear, and then press down and it'll clear the entirety of the list. So I can do that here. Press clear, press down, it clears list 2. The other way that you can do that, now here's the only reason I would suggest maybe not using that method. If you accidentally press the delete key instead of the clear key, it's actually going to delete the list entirely and you will no longer have list 1, which is a pain. You have to reset the calculator to factory settings in order to get them back. So the other way that you can do it is by going to Stat choice 4 and then typing in the name of the list that you want to clear. So I already cleared list 1 and list 2, so if I press second 3, it'll type L3, press enter, it tells me done. Now if I go back to my lists, I can see that it did clear it for me. All right, so once I know that I have my lists clear, I'm going to actually enter my data. So I'm going to do my weight data here in my list 1, and I'm going to then do the miles per gallon data in list 2. So I'm just going to go ahead and enter each of these. So you should do the same because you definitely want to make sure that you can press the buttons yourself. Watching me press the buttons is not going to be nearly as effective. Okay, once you've entered the entirety of a list, I very strongly suggest that you take the time to go back and double check it, because if you enter your data incorrectly, then your correlation coefficient is going to be wrong, your p-value is going to be wrong, so it's just worth the time to double check it. So I'm doing that now. 18027403270. Okay, I double checked them, so now I'm going to go over to list 2 and I'm going to enter the miles per gallon data. So 33, 31, 29, 25, 24, 36, and 30. And again, strongly suggest taking the time to quickly just run through it, double check it, make sure that your data looks good, which I did. So we're good to go on the entered data. So, oops, whoa, don't know what I did there, but it was not what I wanted to do. So now I'm just going to do the 3 methods in order. So I'm going to do the p-value method first, and I enter my data into my lists, and then I'm going to press Stat, scroll over to Tests, and I'm going to choose choice F for linear regression t-test. So Stat, Tests, and then I need to find, it's F, so it goes through the numbers first and then the letters, so it's actually quicker to scroll up rather than down. So here I can see linear regression t-test. I'm going to select that. Then it's going to give you some prompts. So it's just asking where your data is. So my X list, yes, is in L1. If for some reason yours is in a different list, you would just press second and then whatever the number of the list is if you needed to change it. My Y list is in L2. I'm always going to leave the frequency at 1. It says, and then I'm always going to use, for this case, the not equal to 0 choice. So scroll down, and I'm going to press enter on top of the not equal to 0. This next one, regression equation, is asking you where you want to paste the regression equation when it calculates it for you. So this one, I believe the shortcut for typing a Y value, is alpha and then trace, and then you could just choose a place. Y1 is totally fine, so I'm just going to keep it there. If you do not have that shortcut because you have an older value of the calculator, you can type the Y's by going to vars, scrolling right to Y vars, then choosing function, and then typing it. So again, I'm just going to keep Y1. If you're not going to remember how to do that, pause the recording, go back and listen to exactly what I told you and write it down on your notes so that you don't forget. So then I'm going to go to calculate, and it gives me a whole bunch of stuff here. This P is what I want. This is my p-value. Now, you need to be very careful with this p-value. Don't just look at the front because it says 3.78. And if that's all you look at, your answer is going to be very, very wrong because you have to look at the entirety of the p-value. This E indicates scientific notation. So what this actually means is 3.78 times 10 to the negative 5th power, which means I need to take this decimal point and move it 5 places to the left. So for method 1, my p-value, I've got 378, and then I need to move that decimal place 1, 2, 3, 4, 5. So 0.0, 0, 0, 0, 378. So I'm going to rewrite it over here. 1, 2, 3, 4, 3, 7, 8. This is my p-value. That gives you a very different answer than if it was just 3.78. So make sure you always, when you're having your calculator give you values, make sure you pay attention to look to see what the entirety of the value is, because that's going to make a big difference. So using method 1, which tells us that our p-value needs to be less than 0.05, which this one is, we would definitely say that using method 1, that this is a yes, that this shows us that we have linear correlation. When I switch over to method 2, I need to calculate an R value, and then I need to find our, I need to find our critical values. So R values, when I look at my calculator, you can see actually in the exact same spot. There's also another way to calculate an R value. So we're going to write this one down. It's negative 0.987 approximately. So R is approximately negative 0.987. So you can run the linear regression t-test and get your value that way. The other way is to go to Stat Calc and run a linear regression itself, which is choice 4. And notice here that my X and Y lists are not the right ones, so I would need to change them here. So L1 and L2. And then again, this is where you would store a regression equation. So alpha trace is the shortcut. Let's say I wanted to do Y2 this time, and calculate. And then notice that I can get R that way as well. So totally up to you. We can get R 2 different ways. If you ran the linear regression and it isn't showing you your R values, it's only showing you A and B, that means that you have your diagnostics turned off, which we can fix that. So showing you all kinds of calculator tricks today. If you press second and 0 and go to catalog and scroll down, need to scroll down for quite a while actually, because notice that this is in alphabetical order and diagnostics starts with D. So we're down to C. Okay, we're getting close. Okay, so you can see diagnostic on and diagnostic off. So if you didn't have R values, you need to go to diagnostic on and make sure you press enter on top of that. All right, so that shows you what you need there. We have seen that R is approximately negative 9.87. With method 2, we compare R to the critical values. So now I pull up the critical values from table A6, maybe, if I can find it. Find the window. I'm going to turn that off and minimize that. I've got too many windows open. There we go. All right, so in this particular example, our n is equal to 7. We have 7 different data pieces for the Elantra, Ultima, Passat, Lucerne, Grand Marquis, Civic, and Accord. So n equals 7, which means I'm down here. And so because it's negative, we're just going to add negatives to this. So what it says, and it didn't tell us what alpha to use. If we're using alpha equals 0.05, negative 0.987 is definitely less than negative 7.54. So at the 0.05 level, we would definitely say yes, it has linear correlation. Even if I use the 0.01 level, I still have a value that is more negative than negative 0.875. So in this case, it doesn't matter which alpha level we use. We can say that R is less than the critical value, which means that this method also gives us a yes. Method 3, which is just based on the R value, we can say negative 0.987 is close to negative 1, which means that this would also give us a yes. So we've used all three methods. In this case, all three methods happen to agree. So we can feel very confident in saying that there is a linear correlation between the weight and the fuel consumption. Now, the other thing that we're going to be asked to do is to find lines of best fit and use them to make predictions. So when you do either method 1 or method 2, the way that you get R and or get P, it automatically asked you, and this is where the Y1 part came into play, it had a regression equation. It is really important that you tell it where to paste it, because if you look now, when I did the linear regression t-test, I had it paste in Y1. When I did the linear regression by doing stat calc, I had it post in Y2. Now notice that these actually give me the same two equations. It's just that one of them, it does the constant first and the x value second. And this one, you know, the value attached to x is first and the constant 55.43 is second. So these actually give me the same exact equation. So I don't need both of them. So I'm going to turn this one off so that it only graphs y1 at this time. But actually making sure that you paste that into your y equals screen is going to be really important, because you don't want to round these values. Your answers are not going to be the same if you do. Now, if they give you a regression equation to use, then by all means do it by hand. So in this case, our regression equation, our line of best fit, is going to be, so regression equation in this case is y is approximately equal to, because I'm going to round when I write it down here, obviously, it's negative 0.00755. Can never get to the right screen. X, and then plus 55 point, and what did it say? 439 approximately. And many times they'll tell you like what to round to. Here I just took 3 significant digits there for my decimal places. So this is my regression equation. So it's saying if my x is 4,320, what would I expect its fuel consumption to be, miles per gallon? So if you weren't using the calculator, if you didn't have the data and you were given this equation, you would just plug this in for x. But because we do, we're going to be more precise. So the way that we're going to do that is, first of all, we're going to make sure that we graph this equation. So I can't see it here. That doesn't mean that there's something wrong with my calculator. It means that I don't have a correct window. So if I go to my window and let's say I want to go from -5 up to the weights. The biggest weight was 4,180. This one is asking for about 4,300. You always want to make sure it goes bigger than the biggest value. And so I'm going to count by, let's say, 500ths. The Y values, which is the miles per gallon, you always go a little below, even though I'm not going to have negative fuel consumption. I'm going to start at -5 because I always want a little leeway to go below what I need. The max fuel consumption that we had was 36. So I'm going to go up to, say, 45 and count by fives. Now if I graph it, I can actually see my line of best fit. If you want to see the actual dots, you can go to second y equals and the stat plot. And so this one has plot L1 and L2. If I turn that plot on and select what's left here, I can actually see the actual values with my line. So make sure you remember to have your plots off if you don't need them, because sometimes that'll mess up some of your other values. So in this case now, if I want to see when x equals 4,320, the way that we do that is we go to second trace, choice 1 for value, and you learned how to do this in Algebra 2. You just type in the x value that you want, press enter, and it's going to spit out an appropriate y value. So we can write this down. What we did second trace, choice 1, and then we did x equals 4320. We pressed enter, and it told us that y should be approximately 22.8, which, because all of these are whole numbers, I'm going to leave it a whole number as well and just make it 23 miles per gallon. All right, C, Mrs. Thomas's Town and Country gets 25 miles per gallon on the highway. How much does it likely weigh? So same idea here, except this time I'm given the y value and I want to find the x value. When I do that, what you're going to do is graph the regression equation, which we already have. That's in my y1. And then in another y, I'm going to use y3 this time because I already have something in y2. I'm going to graph the y value that they gave me. And then I'm going to find the intersection, which is another thing you learned how to do in Algebra 2. Use the second trace intersect feature. So I'm going to review that here. So I'm going to go to my y equals. I'm going to scroll down to y3 and type in that y value that they gave me, which was 25. I'm also going to go ahead and turn my plot off now because I don't need it. I'm going to go back and I'm going to press graph. And if you can't see the intersection, you would change your window again, but we can in this case. So second trace, choice 5 for intersect, and scroll away. All right, enter, enter, enter 3 times, and it gives me the intersection. So I already knew what y was. I was looking for x, so it looks like approximately 4,033 pounds. And that gives us our answer. Now, something that is very important because this, I promise you, will come up in the homework at least once. And I have seen it on the final exam before, not necessarily every year, but it's really important that you know how to do this. They will try to trick you and they will ask you to, do predictions or find the line of best fit, find the regression equation for data that does not have linear correlation. If there isn't linear correlation, you do not use the regression equation line that you get from the t-test or from StatCalc. The equation in this case would just be y equals the mean of the y values. So in this case, you would take all the y values, which 33, 31, 29, 25, 24, 36, 30, you would add those all up and you would divide by 7. And y equals that number would be the equation that you would use, which means that regardless of what your x is, your y would equal that particular number. So this, I put a star by it, I put it in a different color because it's really, really important. You need to make sure that you know that if the answer is not a yes to linear correlation, that you don't use this, equation from your calculator. You use the mean of the y values instead. All right, so now you know what to look out for, and I think that about does it for our linear correlation.